Okay. 8 rowers in a racing boat strokes that the angles formed by their oars with the side of the boat all stay equal. Explain why their oars on either side of the boat remain parallel. So what they're talking about is that all of these oars are parallel to each other and all of these oars are parallel to each other. They're clearly not all parallel all the way around, right? But on each side they are. Now, let's just talk about why that is. So I just pulled this illustration. There's not 8 rowers here. There's only 4, but this will illustrate the point. Okay. Essentially, um, if we know that all of the angles formed by their oars are uh, the same measure, equal in measure, right? Then what we've got here is we've got corresponding angles because essentially what you have here is this. I'm gonna draw the parallel lines. I'll straighten these out in a second. Okay. What we've got here is parallel lines and cut by the transversal, which is the side of the boat. Okay, so the side of the boat here. Oops. Uh, like that. Okay, and when we've got that, then you can see that these truly are corresponding angles right here. And when corresponding angles are congruent, that means that the oars in this case must be parallel. Okay, so that's essentially the explanation in words, is that through the converse of the corresponding angles theorem, and actually maybe I should just write that because it's worth actually naming out loud what it is. Okay, the converse of the corresponding angles theorem. Okay, essentially states that if corresponding angles are congruent, and they're telling us that they are, the angles formed by the oars and the sides of the boat all stay equal, then if corresponding angles are congruent, then we know the lines are parallel. We've proven the lines parallel. That's when you use the converse of theorems for that. Okay, there you go. That's pretty much it.